Hi there. Thanks for joining me today on this session on getting started with the Farmstack. My name is Bassett. I am a Principal Developer Relations Engineer over at New Relic, where I'm part of the Relicans. You can find me online mostly as either Aaron Bassett or Aaron Bassett Dev on Twitch. All of my contact details are on developer.newrelic.com. You can see here you've got my Twitter, my GitHub, etc. So if you'd like to follow on with the code today, it will be published on my GitHub. There also will be a link in the video description, I believe. So please go and download that, and then hopefully you can follow along as we walk through this session today. So before I joined New Relic, I actually was with MongoDB. And while I was with MongoDB, I wrote this article on introducing Farmstack. So Farmstack is very similar to, you may have heard of like MERN in the JavaScript world, but I wanted a MongoDB asynchronous stack for Python. And I came up with Farmstack, which is FastAPI, React, and MongoDB. Now don't worry if you've not heard of FastAPI or React, etc., or any of these kind of other stacks I've mentioned. We'll go through that in a little bit of detail first, but I wanted to go over what we're actually going to be building. And we're going to be doing a to-do app. So in web application development, when you're looking at different frameworks, etc., the to-do app is essentially a hello world. And it's pretty good because it demonstrates CRUD, which is the create, read, update, delete. So here we can see I can like create a new to-do, I can see the to-do on the page, I can like mark it as completed, and I can delete it. And each of those is one element of CRUD. So I have my create, which is my C. My read is here, where it is showing me the to-do on the screen. My update is being able to mark it as completed. I'm updating that database record, and then my delete as well, deleting it. So to-do app, great demonstration of the principles of CRUD, and that's what we're going to be building today. Now the way I have this structured, if you do download the GitHub repository, is it's kind of in logical commits, and I'm going to work through pretty much every commit in order and walk through the code, or at least the most relevant, interesting parts of the code from it. I'm not going to make you watch me live code this. I'm only going to show you the bits that are really most relevant, and we're going to skip all the boilerplate. So what is Farmstack? It's FastAPI. So FastAPI is a asynchronous Python web framework. It's pretty new on the scene, but it is really already very well established. Great documentation. It's being used in production by some big names. There's references from like Microsoft and Uber and Netflix, etc. So don't be put off if because it is relatively new in web framework terms. It is already very mature. It's my go-to anytime I need to do kind of an asynchronous web API in Python. I pretty much am always turning to FastAPI these days. So FastAPI is our F and our A in the Farmstack. Our R is React, which is a JavaScript framework for building user interfaces. React allows you to break your interfaces down into components. Does a great job of doing kind of your mapping your data to your DOM, etc. It uses JSX, which is kind of an odd combination of, well, I would say odd. It takes a little bit, it took me a little bit getting used to, shall we say, of JavaScript, HTML, and CSS. But we're going to look at some React today as well. We probably will spend a little bit more time in Python than we will in React. But I will show you how to create that basic kind of React interface, that UI in the browser, and how that connects to your FastAPI server on the back end, and then how your FastAPI server talks to the M in Farmstack, which is MongoDB. Now, I am using MongoDB Atlas here. MongoDB Atlas is MongoDB's hosted service, their cloud managed service. You do not need to use Atlas to work with FastAPI or React, etc. I'm using it here purely for convenience, so I don't need to run my own local MongoDB cluster, but anything that I'm doing here will work perfectly well with the community version of MongoDB. There's nothing proprietary here. I'm not using anything to do with Realm, etc. This is just using, kind of standard MongoDB. I'm only using Atlas in this instance purely for my own convenience. So if you want to run this all locally, that'll work perfectly fine too. Okay, with that all said, let's start looking at our actual code. So I have two different servers running right now. This is my React server. The React server, I'm running a React server because it's in development mode. So this will detect any changes to my JavaScript files and it'll automatically live reload those into my browser. but we're going to be doing a lot of kind of modifications first before we get to the front end side. So I'm just going to close the server for now. And I also have my Python server here, which has been running for a while. So I'm actually going to close that too. And then we can start looking at our Git commits. So looking at our Git log, I'm really going to kind of step through these, not every individual one. We're not going to like go right back to initial commit, but let's go right back to our create backend structure here. So I'm going to check out backend structure, and then let's look in our editor. So here we have this backend folder, and this is going to hold our FastAPI server. So this is where all of our Python is going to live. And in the backend folder, you can see we have this main.py. That's going to be our main entry point. That's how we're going to run our server. It's going to contain our FastAPI app. We have a config.py, which is where we're going to have some settings, including our connection details for MongoDB. And within our apps folder here, we have this to-do folder, and that's where we're going to define our models, so how our data is structured, and also our routers. And the routers are where we're going to define the handlers for the different API URLs that we want to create. So there's nothing in these at the moment. If you are following along and you've downloaded the repo, and you've checked out that commit, yes, these files should all be empty. This is just a structure, so I can kind of give you a little overview. Also, you may notice you might not have a front-end folder, and that's perfectly fine. I have a front-end folder here because it just contains my Node modules, which are not checked into Git for obvious reasons. But I'm leaving this one here, so I don't need to do a full npm install during this recording and make you sit and watch that. So if you have downloaded it and you don't currently have a front-end folder, that is to be expected. Don't panic. We will create the front-end folder a little bit later on in this session. So now we can see the basic structure. I need to check out my main branch again, just so I can view my Git log. And now we can see that we're going to do our add app settings, just to show you kind of what we need from MongoDB or how we specify our connection strings. So I'm going to check out that commit. And if we go back into our config.py, we can see we now have a few different settings here. Most of them are pretty standard. I'm defining an app name and whether it should be in debug mode. Here I'm also defining, this is going to be running on my local host, and our Python server, our FastAPI server, is going to be running on port 8000. And then we also have this database settings, and this is where we're going to define our MongoDB connection strings. Now you can see I do not have anything defined here. I'm just setting DB URL and giving it a type of string. I don't have a value for it. These are actually going to be populated from my environment. So I have environment variables, DB URL and DB name that are already set, and they contain my connection string for MongoDB. I haven't put them in this file because I don't want them to be public, and I don't want to inadvertently disclose them on this stream. So they are. You're gonna have to trust me that it's just a regular MongoDB connection string, and it's currently stored in my local environment variables. So that'll be populated in there for me. So how do we actually connect to MongoDB? So let's check out our main branch again, so we can get our next commit. And here we've got our connect to MongoDB. So now we're going to be in this main.py. And main.py is where we create our FastAPI app, but it's also where we're going to connect to MongoDB. So here I'm using the Motor Async.io Motor client. So Motor is a Python driver for MongoDB. It's one of the official Python drivers, and it is an async driver. It's a wrapper around PyMongo, which people might be more familiar with, that allows it to be asynchronous. And as FastAPI is asynchronous itself, it makes sense to use the asynchronous driver, just so that our queries to MongoDB don't become blocking as part of our request. Now in FastAPI, we have this idea of events, and we can decorate different functions and then define which event it is that we want to trigger this function on. So here we have our startup event. So this is going to be run whenever our request starts. And you can see here I am creating a MongoDB client using our motor driver, and I'm passing in that DB URL that we talked about just a moment ago. I'm also creating just this MongoDB itself, which is going to be a reference to the database. So I have both the client and the database here referenced on app. Defining them on app is kind of important. As you can see, I'm not actually won't be doing any queries to MongoDB within main.py. These are all going to be within our routers, which are in our to-do app. But I don't want to have to instantiate a new MongoDB client in each router. I would rather have one that is used for the whole application itself. So I define it here in our startup event, and I attach it to the FastAPI app, and that way it will be available within my routers. We also do a little bit of housekeeping, and we have this shutdown event, and whenever our request is finished and our app is shutting down, then we call MongoDB close, and we close that connection, just to kind of keep things nice and neat and tidy. Other things we have in this app is just running our UVcorn instance here, which is going to start up our actual app itself. And you can see, again, we have those different settings being passed in. So what host is going to run on, what port it's going to be available on, and whether or not it should be in debug mode. So next up, we have defining our models. So let's just check that commit out. And this may seem a little bit odd for some people who use MongoDB or have heard of MongoDB, because one of the big selling points of MongoDB is that it is schemaless, that you do not need to define a model for your data. So why am I now jumping straight into defining models? Well, that's true that it is schemaless. That doesn't mean you can't use models in MongoDB, and models sometimes are really useful, and it allows you to do like data validation and ensure that your data that you're actually sending to MongoDB is valid and correct and well structured, etc. Just because MongoDB is schemaless doesn't mean that you can't enforce a schema on it. So in our models, we have a couple of different models defined. So the first one is our task model. And here we can see we have an ID, we have a name, and we have this completed, which is Boolean. So the first thing we should note is this ID has an alias of _ID. In MongoDB, it will create the IDs as _ID. And that's perfectly fine, but in Python, an underscore in front of a attribute has special meaning. It means it's private. So if I had called this _ID, then Pydantic would think that this is actually a private attribute and wouldn't create it as part of my model. So I need to use call mine ID, but then I'm using this alias to say that I can also reference it as _ID, or it should be stored as _ID in MongoDB. So this will actually be stored as _ID. I'm also defining this default factory. So MongoDB will, if I don't supply my own ID, it'll assign an ID for me. And whenever MongoDB assigns an ID, it's going to assign it of a type object ID. So MongoDB is BSON, which is essentially a superset of JSON. So it's JSON, but with a few extra data types. And one of those additional data types is object ID. Now, whenever I'm using FastAPI, it's going to be serializing and deserializing my Python objects into JSON strings, and from JSON strings back into Python objects. If I have a JSON string that's coming back, or sorry, if I have a part of my Python object, if one of the attributes is of type object ID, that's not a native JSON type, and it's not something that FastAPI knows how to serialize or deserialize. So I could write my own serializer, deserializer for it. There is tutorials out there on how to do that. But in this instance, really, I'm perfectly happy with my ID being a string. So I am going to be just using a UUID for that. And that's just going to be setting my ID as a string. So I don't need to worry about serializing and deserializing, as that's a native JSON type. Next thing to bear in mind is this name field here. This syntax may look a little bit strange. It just means that the name is required. I'm not setting a default value for it, but it should be required. And then finally, we have this other class of config. This allow population by field name is to do with the alias, to allow me to populate it either by ID or by _ID. And then the schema extra is really for documentation, and we'll see how that becomes important very soon. Essentially allows me to here to define a example set of data. So whenever we look at our interactive documentation, we'll see this as an example of the type of request we can make. The second model we have is an update task model. So this is for whenever we're creating a new task, and this is for whenever we're updating an existing task. And the difference here is, one, that these values are optional, because we may not want to always update both the name and the completed status. We may just want to mark it as completed but not change the name, or we might want to say, oh, this is not completed yet, but I spotted a typo in my name and I'm going to change that. So these are optional, which is the first thing to notice here. Also, we do not have an ID. So I am specifying here that ID is not something you can update. Because ID, once it's set during the creation, that should remain static. You should never really be changing the ID of your task. So it's not specified in update here, you'll not be able to change it. And we have that schema extra to show the difference in the data that we're going to be sending. So next up, we are going to be looking at our actual routers. So we're going to be creating our CRUD routes. That is our create, read, update, and delete. We actually will have 2 different routes for reads, and I will show you why that's important just now. So in our routers then, let's go right back to the top so we can do them in order. So the first one we have is a create task. So that's a C in our CRUD. And our create task is always going to be a post request. And we can see here that it takes the request that's being made, and then it has this task model. So that was the one we just looked at a second ago in our models. First thing it does is it is going to convert that JSON string. This is where we're talking about kind of this serializing, deserializing back into a Python object. And then I'm going to insert that into our MongoDB. So here I am just sending that directly to MongoDB. I'm not making any modifications to the data. I'm not doing any verification of the data. I'm not like assigning a user or checking any permissions, etc. If this was a production app, you probably have to do a little bit of data transformation, a little bit of business logic to ensure the person had rights to create a new task, etc., etc. But we don't even have authentication on this at the moment, so anybody can create a new task. There's no user information stored against it, etc. We're just taking whatever data we get from the client and we are creating a task with it. If you'd like to learn about how we do authentication in the Farmstack, I do also have another tutorial on the developer.mongodb.com about adding authentication, so go check that out as well. So once we have inserted our task, what MongoDB is going to return, it won't return the document that was created. Instead, we will get this inserted ID. So what I then do is I'm going to make a second query to our MongoDB, to our database for that document, so I can then return that as part of the response. And this is where we can see here, all of these requests are being made on, this is our app where we created our MongoDB instance, and that app is available on the request. So that was why it was so important for us to add it to app, so it would be available within our routes here. Next to note is that I am returning this JSON. Now FastAPI, if I just gave it a Python object, it would know what to do. It would know that I just wanted to return a JSON string. The reason I am specifying a JSON response here is because I want to change the status code that's sent. So by default, it's going to return a HTTP status code of 200, perfectly valid. But in this instance, there's actually a more specific status code that we can send, which is a 201, which is the HTTP status code for created. So that is essentially, yes, everything went okay, and we've created your new object, and here it is. And then it's going to return the actual created task that we looked up here in our find one. So that is our create. Next up, we have our read. Now for read, we actually have 2 different handlers. First one is going to get us a list of all of the existing tasks. So that's just going to be a GET request. Again, we can see there's like a little response description here, which is going to be part of our documentation in a moment. And all it's going to do is it is going to create a new empty array for our tasks, and then it is going to make a request to MongoDB for all tasks. Essentially, because I'm not defining any kind of query object here, my find is empty. It's just going to return everything that's in this collection. Now, I am putting a limit of 100 on the number of tasks I'm returning. If this was a production app, you probably wouldn't want to hard code that limit in there. Instead, you would want to have some form of pagination, so the ability to return 50, 10, 25, whatever the number is, return a certain number of tasks at a time, and then allow people to request the next page of tasks, etc. For this demo, I know I'm never going to have more than 100 tasks in my database, so I just hard coded the limit at 100. So we iterate over all of the documents that are coming back, and then we append them to our list here, and then we return that. And because we just want this to be a regular 200, I don't need to specify anything else. FastAPI will know if I just give it a Python object that it can serialize, it should just turn that into JSON string and respond with it and give it a status code of 200. The second read that we have is for an individual task. So given an ID, just return one task. This is returning all tasks or a list of tasks, and this is going to return just an individual task. So it's still a GET request, but rather than just to the root path here, we are specifying an ID as part of the path as well. Our function then is going to get that ID as an argument as well as the request, and then we are going to do this lookup on MongoDB. So we can see here that we are doing our request to our collection. We're asking it to find one, and then we're specifying that underscore ID is equal to ID. Now, this is a pretty new feature of Python. This is the Walrus Operator, as it's commonly known, and it allows me to do both a assignment and a check in one line. So I'm doing assignment, I'm a conditional here. Essentially what will happen in this instance is if this finds a document, then task will be set to that document. If it does not find a document, then task is going to be set to none, and you can see here I'm doing this check is not none. So essentially I'm doing my assignment and my conditional check all in one line. If task is not none, then we can return it. Again, FastAPI will convert it to a JSON string, etc., etc. If we don't return here, then we're going to raise an exception instead. And we can see we're just raising a regular HTTP exception with a status code of 404, so a not found. Next up in our create or CRUD, so we've done our create, we've done our read, now it's our update. So an update is kind of a combination of these two. So first of all, we need to know what task it is we're going to update, so we're going to need to have that ID, and then we're going to take some data to update. But because it is not creating a new task, we're not going to use post, instead we're going to use put. So with our update here, we still receive the ID as part of the URL, but we also have this update task model, which is going to take the values from our body. This line here ensures that we don't accidentally update some of the values to empty strings. So because our values are optional, it could mean that they're sending the completed status, updating that to true, but they've also sent the name, but it's an empty string, or it's some other value that's going to equate to none. So what we're going to do, first of all, check is that only the key values that we have in here actually have a value, so we're not accidentally deleting data from our MongoDB database. Next thing we're going to do is check that we do have something to update. Because both fields are optional, you could make a request to this endpoint with an ID and no body. It wouldn't really make sense to trying to update something without actually specifying any data updated to, but we're just going to do a little double check for that just in case, a little bit defensive programming. So if we do have some data that we want to update, you can see here that we are using the update one, and we have two objects here. The first is going to be our condition. So this is where we're saying, okay, we're going to use ID equal to ID. And then what we want to do as part of our update is we're going to set any of these fields. So that's where we're passing in this task object. So that'll be our different fields like name, completed, etc. Our update result is going to return a result set, which should have a modified count. If the modified count is equal to 1, which it should always only be, it should never be higher than that, hopefully. So if it's equal to 1, then we know that we have successfully managed to update a document. So what we want to do at that point is then find the document that we just updated. So we're going to do another find here for that ID. And as long as we can now find a document, there's no weird race condition where in the time it's taking, from between our update and our find, and somebody else has managed to delete it, for example. So as long as that task is not none, then we return that updated task. If we don't have any fields to update, if we're in that weird condition, then we just look to see if there is a task with that ID. Okay, we don't need to update it, but we still should probably return it, and then we, again, return it. If we get to this stage where we've not yet returned a task, we've not been able to successfully update a task, nor have we found an existing task with that matching ID, then again, we just return a 404. And finally, we have our delete. Delete is very similar to our put and our get in that it requires an ID. We can see here that we have all of this is operating really on the HTTP method that you're sending. So you can see that our URL is pretty much the same the whole way through. It's either just the / or it's a / and an ID, depending upon whether you are creating something new, so doesn't yet have an ID, whether you're getting a list, so you're not specifying multiple IDs, or whether it's an individual item that you're acting upon. So we're not creating different routes. We don't have like a create route and then an update route, and then we have the same endpoint, and then it's really differentiating based upon the type of request, so the HTTP request type that we're sending. So in this instance, we're going to be sending a delete request. We're providing the ID as before, and we are asking MongoDB to delete one where ID is equal to, our underscore ID is equal to ID. If our deleted count returned from MongoDB is equal to 1, so we've managed to successfully delete that object, then we're going to return this HTTP 204. This is the only time we're not actually returning, except for our 404s, of course, that we're not actually returning a document to our client as part of our response. Because at this point, we don't have a document to return. We've just deleted it. So instead we're going to return this 204, which is a yes, we managed to execute your request successfully, but we have no content to show you. I have also seen people just sending back a regular 200 and the document that was deleted. Up to yourself as to what you do here. I prefer setting a 204 no content to show that yes, it was successfully done, that you haven't accidentally run just a read request and you're getting it back, that it has been deleted, and we can see that from the different status code. If we get to this point, so our delete account is not equal to 1, then we're going to raise in our 404 and say again their task wasn't found. So that is all of our different routes that we're going to have. So let's go back and see where we are now in our log here. Okay, so now we have our routes created. We have to add them to our FastAPI app. So this is the last step before we can actually start looking at something in the browser. We haven't created our front end yet, as you know, but this is really one of the big selling points for me of FastAPI is what we're going to see in just a moment. So we've created all these routes, and now if we go back to our main app here, we can see this is what we had before, where we create our FastAPI application, we have our on events, startups, and shutdowns, and then here is where we're attaching those routes to our application. So we're going, okay, include router. Here's our router, which is what we're defining here. So we define that right at the top. Our router is equal to our API router. So we're passing that in here. I'm importing it as to-do router just to keep it nice and organized. We don't have lots of things just called router that I know that this one is being imported as to-do router. We're passing that in, so it's being attached to our application. We can add some tags to it, etc. And then this is a prefix. So this is where it'll be available at. Will be at /task. Will be the endpoint. So all of those we're going to hit task, and depending upon whether it's a post request, get request, put request, delete request, etc. is how it's going to differentiate which handler is going to be called. But we only have this one endpoint, which is task. So now we have all of those created. Let's give this a try. Let's see what happens. So we're going to run python-main.py. Okay, so our server is up and running, apparently. Let's go have a look here. Yeah, I think I should just be able to do that. Okay, so we're saying not found because we didn't define anything for our default route here. But if we go to docs, this is what I was talking about with FastAPI. This is the bit that, first time I saw this completely blew me away, is we have this full Swagger UI, so interactive documentation for our API, and we didn't need really to do an awful lot to get this. This is not something that I've, secretly coded and it's not shown you. This is just what you get out of the box with FastAPI. And the only thing I really did to help with the generation of that was that few little things you've seen here. So in our models, this example, we'll see that these are available in there. And also these little response descriptions we can see are in here too. So first one we want to look at is our create. We don't have any tasks yet, so we're going to create a task. We can see here, there's our example, etc. But the really interesting bit is we can go try it out and we can run this request. So I don't actually need to specify an ID. It's going to generate one for me, but I'm going to keep those values, execute. Okay, so we can see here, this is the request that it made, the request URL, so the /task, and then what we got back. So we got our 2 or 1, which is what we expected, our object created. And we can see our response body here returned that new document with an ID set. So if I go to my MongoDB collection here and go have a look. Okay, so there is my new task. So this is definitely being stored in MongoDB. What we can also do is really just work through them. So I'm going to grab that ID for my new task here. I'm going to need that in just a moment. And I can now go list tasks. And I'm going to try it out, execute. Okay, so here we go. I've got my task is in there. If I was to create another task, let's just create another important task. Run that. Okay, so yep, 201, great. Let's go back to our list tasks and execute that again. We can see now we have 2 tasks. Perfect. If I now go to this show task and try it, I can specify the ID. So there's that ID of the first task I created. Run that. Here we go. We are getting just our single task back. I can then, again, do our update. I'm going to specify our ID here. And I'm going to, let's not change the name, but let's just mark it as completed. And we're going to execute that. Okay, let's see down here. Yep, our 200. Let's check in MongoDB if it's showing the same values. Great, so we have 2 different tasks. We have another important task and my important task. One's been completed, one hasn't. So this is all being saved correctly into our MongoDB collection, and we can delete a task as well. So I'm going to just run that. We can see here there's our request URL that we hit, and we've got our 204 back. So that's correct that it has now deleted it, but it doesn't have a task to provide for me. And I can even go, let's go show task again. Let's rerun this, and we now get our 404 saying that task with this ID was not found. So that's really our FastAPI kind of created, and we have a full working interactive documentation now. So let's go, I can stop the server, and let's look at how we'd link this to the front end. So I'm going to check out my main again, look at our logs here. So we've now done all of our FastAPI work. Hopefully you've managed to follow along on that. And now we're going to create our front end structure. So our front end structure, I just use create React app. What it gives us, let's have a quick look, is this kind of front end structure where we have everything is really in this source directory that we're going to be using today. And it has created this app.js for us, which is essentially just the React JS logo and some text. We should be able to actually run that. Let's go start our server here. So we're going to do a yarn start to start our React JS server. It takes a little second just to compile everything and get it up and running for us. So let's wait here. You can see it's refreshing this page. Okay, so here is our default React app. This is what you get whenever you run create React app. And it creates a little bit of boilerplate and scaffolding for you. So let's get our next one. Okay. So we are going to just add a static layout. What I mean by static layout is I normally do this anytime I'm creating kind of a web application. Is I'll first of all just create the different components that I need, but without actually fetching the data from the server. So it's just going to be static data, normally just some kind of inline data in the app itself that allows me to kind of lay out what it's going to look like, etc., without actually working with the live data just yet. So let's go look at our app.js. So it's changed a little bit here. We can see now that we have a little div, which has got our divider at the top, which is going to show this little title that we have. And then we have our form. So this form is what's going to include our input to allow us to create a new task. It's going to have our input and it's going to have our button there as well. So we can see here we have our input and we have our button. We're saying, yes, this is required. If it's not filled in, it's going to say, please input a to-do. We also have here our timeline. So this is what's going to show all of our individual to-dos. They're going to be shown as timeline items. And that's going to have this little circle at the side that we saw to show whether it's completed or not. and then it's going to have like the task name, and this is going to be the ID of the task, that UUID. So we check now, this should have restarted, hopefully automatically. We go to our front end, here we go. So this is all static at the moment. It's not actually going to do anything. None of this stuff is actually linked up. It's just the static HTML, CSS, and a little bit of JavaScript to do things like validation, etc. So now what we want to do is start linking this to our FastAPI server. So I'm going to check out main again and look at my log here. And we've got our static layout. So the first thing is fetching up to-do items from server. My dog's very excited by the idea of us linking our front end and our back end. So let's grab our commit. And let's go have a little look here. So now we are using state. So state in React is how we are going to be storing some of these things. And the good thing about state is that we actually can use hooks to trigger different actions when our state changes. So you can see we have two things we're storing. We're storing our tasks and we're storing our timeline. And the tasks are going to be the data that we fetch from the server, and our timeline is going to be what we render down that right-hand side. So for each timeline item, we're going to render out a new kind of entry in that right-hand bit. So first of all, we have this use effect, which is one of our hooks I briefly mentioned earlier. Use effect is triggered whenever, first of all, this one's going to be triggered whenever the component is first loaded. Here was where we'd specify or whatever this value changes. We don't have anything specified here, so this will only run whenever the component is first mounted. And what we're going to do is we are going to fetch all of our tasks. So we can see here that we have this fetch, and it's running on our task endpoint. So it's just going to do a GET request. We're not specifying any IDs or anything like that. So this is going to be our list handler is going to get called here. It's going to return a JSON string. So we need to convert that back into a JavaScript object. And then we are setting our tasks to what was returned from our API. Now, I also have this interval I'm creating here, and that's just going to run once a second to fetch more from the server. So we are polling the server to approximate kind of real-time interaction. I would probably be running this as like over WebSockets, etc., if it was in production. But for this example, that's perfectly valid. So we can see here that we have this interval that's going to be running every second. And then we have, whenever our component is unmounted, it's going to run this anonymous function here. And that's going to clear our interval. Just, again, a little bit of kind of housekeeping. Now, our second hook, it's going to run any time that this task's value changes. So our task value can change anytime this runs and there's new tasks, or a task object has been modified. So whenever this is updated by our fetch function here, then it's going to trigger this hook. And what this hook does, it's going to create all of our timeline items. And these timeline items are going to be what's stored in this state. So for each of our timeline items, we have a little conditional here that's going to just do a small modification to the timeline depending upon whether it's completed or not. They're pretty much identical, except for we're setting the dot to be either a check or a minus, and we're changing the color from like green or blue, and if it is completed, we're running a line through. And then we can see here that we're also setting the task name and that task ID that's being returned from the server too. So once all that's complete, we set our timeline to these items, and we can see here in our what we're rendering is that timeline is going to be rendered down here. So that's going to be the bit down the right-hand side. Now, right now, we don't have our ability to create new tasks or anything. This is only doing the read part of our CRUD. So let's go have a look at that. And I'm going to let you in a little secret here. I think when I try this, it's not going to work. I'll explain why in a second. So first of all, we need to have our backend server running. So let's run our backend server here. So we're going to do main. Okay, so it's our FastAPI servers up and running. And now we are going to run our React server. So we're going to do our React start. It's a little second for it to start up here. See this refresh in a moment as it starts. Development server starting. We do have, we should have one left in here. I only deleted one of them. So we do actually have it to do in the database. But if we wait for this to start, it does take a little bit longer. Now I've done some modifications to the code. The default React app obviously renders faster. Oh, we do have another important task. Okay, I was unsure if that was going to work because we need to do what's called a proxy. And I didn't think that we'd done that just yet, but I'm obviously one step ahead of myself in this one. And in our package.json, we have this proxy. So what that means is, let's just have a look at our app.js again, is here I'm specifying, our /task, but I'm not specifying like the whole URL, I'm just saying /task. And what React is doing is going, oh, I don't recognize this, so I'm going to proxy that request to port 8000 because our React app is actually running on port 3000, but it's proxying any request it doesn't recognize over to our FastAPI app. So I actually was a little bit ahead of myself there. I was so certain that that was not going to work because this wasn't in our package.json, but I already added it in. So that's even better. So next step up, we now have all of our read done. I'm going to check out main here and look at our log again. We have our static layout we've done. We've done our fetching of to Amazon server, create add task form. So we're going to check out our create add task form. Stop our Python server. Make sure it's on the correct head as well. 426, yep. So we can start the server up again. And we can start our yarn start. Probably just leave this running and open a third terminal window to do our checks for these, so I wouldn't have to keep waiting for it to compile our development server, but at least it gives me a second to drink some seltzer water. So development server is starting up again. Our Python server is already running, and we should now have a working create button if we give it a second. Okay, so we're still seeing here's our another important task. That's one we created, so we're going to do a new to-do, add. And here's our new to-do. So this has gone from our React app to our FastAPI server, and then from our FastAPI server to MongoDB. Refresh here. And we can see there's our new to-do. And then what our React app is doing once a second, as we discussed earlier, is then fetching any new to-dos from our FastAPI app. So it's actually doing a create, and then it's doing a fetch later, and that's updating this list for us. So finally, let's do that, what I was saying, and just check out another terminal window. So I need to keep restarting that server. So let's do a git checkout main here. We're going to do a git log. So our create add task form, add ability to update task status. So let's have a look at this. This is going to be the U in our create read updates. We're almost through all of them, and let's look at actually the handlers for these. So they're all going to be very similar to our fetch, but now as well as having our just a regular get response, we can see that. Let's look at our different ones. On our button here, we have this onClick event. It's got our save task. So that's going to call this function. It's an async function. It is looking to make sure that we do have this new task set so that there is a value in our input for a new task. Making sure we've got new task set, and then it is doing a request to that same endpoint to task. As we discussed before, there's not multiple different endpoints depending upon, it's not like task /create or task /delete, it's just task. And then what we do is we modify the method. And here we can see we're setting the method to post. So our FastAPI server is going to know that this is a create we're asking it to do. We're telling it, yes, it is application JSON. So we can set the body to just be a JSON string. And in that body is where we're saying, okay, here's the name of my task. And we're just saying that it should be false. We don't give them the option of like creating a done task. Any new task that's created is going to be created as false. So that's for our save, and for our update, very, very similar. In this instance, however, we're going to get a task ID, and we're going to get the status. So whenever somebody clicks on this little, where we got it, it's going to be up here. So somebody clicks on our little circles, to the side. Let's have a look in our browser so I can show you. I mean, these little things here. When somebody clicks on one of those, then it's going to trigger this change status task. And our change status task, depending upon whether it is currently complete or it is incomplete, is going to set the value to the opposite. So if it is currently complete, it's going to set the value to false. If it's currently incomplete, it's going to set the value to true. And it's going to send us task ID so we know which one it is that we want to modify. So in our change task status, we can see it receives that task ID and the status from our click event. And then it's going to do another fetch. This time we are passing the task ID as part of the URL. So I'm using a template literal here to essentially concatenate those strings. This will be replaced by the task ID variable. And because we want it to be an update, we are changing the method to put. We still specify that the content type is going to be application JSON because we are going to be sending a body on this request. In our body, we're just going to be sending the completed status. Because remember, we don't need to send also the name. We don't need to send both of those. If we look again back at our model here, our name and our completed are both optional. So we do not have to send this each time. We can just send the completed, and that's what we're doing. We're only sending the completed status. So here we're just setting that completed to whatever is passed in, whether it be true or false. Thing to notice is we're not actually doing anything here or here with the return value. We could. Our API is going to be returning the new task that is created or the task that's modified. Remember, in our routers, we do that. We return, the created task, or we return the updated task. So do get that back as part of the response. We could then go and update the correct to-do item or task in our list based upon the ID that's returned. But because we are doing that polling, and I know that it is going to request all of the tasks again, less than a second after I've done this, I'm not doing that at this instance. I probably would recommend that if you weren't doing polling or you had a much longer list of tasks or whatever else, this would be a more instantaneous way of doing it, of just getting the return value from this request. And then we could immediately update the task to what has been returned. But it's going to be such a short space of time between, well, I think, is my server still running? Let's look. Yeah, so it's running and it's running. Let's just, so you can see what I mean. So here I'm clicking it, and it's done. Click again, undone. Click, done. Click. Oh, missed it. Click, undone. So it is about a second is the maximum I can get here before it's going to respond to me. So it feels pretty instantaneous. But in production, I probably would update the UI immediately, send a request to the server, and then ensure that it balanced the two, that my UI did actually reflect what was being returned from the server itself. Okay, so our final bit then is we now have if we look at our front end here, we have our ability to create. So let's do a third task. So we have our ability to create, we have our ability to update. We can see them here, so we have our ability to read. The only thing we're missing is delete. So we are going to check out our very final version. So I'm just going to go git checkout main. Hopefully this should cause these to automatically rebuild for us. And it has, because now in our browser we have this little red icon here. So let's look at our delete request. We have modified this response that we now have this delete outline. So delete outlined is a component that is just simply this icon. And we have this on click event, and all it is doing is passing the task ID to our delete task function. And our delete task function down here takes a task ID and it calls just that task endpoint with the ID and sets a method to delete. So we don't need to pass anything additional here. There's no body. We don't need to pass like any additional information. We're not setting a name or updating any of the details. Just the fact that we are using the HTTP method delete is enough for our server to know what it is that we want to do. And if we look at our router again here, router delete, if it's got an ID, it just deletes it. So by using the HTTP different methods, it means we can keep our API really, really neat and tidy, that we don't have to have lots of different namespaced task / whatever in order to execute stuff. So we have our delete here. Let's make sure that it actually works. So this task is done. We can delete it. Wonderful. Never important task we can delete. So we can keep doing those. We now have no tasks left. Let's go check in our database here. Yep, no results. Let's go create some tasks through our just FastAPI's, our interactive documentation again. So we have, let's do a final task. We're gonna execute that. Okay, so we're getting 2 more back. Let's go look at our MongoDB, refresh. Okay, final task here, completed is false. And if we look at our front end, there's our final task. Again, let's do it from the other direction. So we're going to do a front end task. Add. You see it appears here in our MongoDB. Front end task. And then if we actually go to Swagger, we can do our list tasks. And we can see it's appeared there as well. So everything is linked right away through your stack. We have our FastAPI, which is talking to MongoDB and also talking to our React front end. So everything is working nicely together. It really does form that kind of that stack, as it were, with FastAPI is sitting in the middle. I really wish that we could have done the initialization in order, but unfortunately having React, FastAPI, MongoDB, the RF AM just didn't have the same ring to it as Farm, unfortunately. And part of the success of any of these things is having a good acronym. So Farmstack it is. But yeah, if you would like to check out more about it, as I said, the full source code for what we went through today is all published. Please go clone that, work your way through. I have tried to keep it as structured as we can here. Let's have a look at our logs. So it has essentially just been everything we've talked through is individual commits. So please, if you would like, rewatch this video, clone the code. I know I went through it a little bit quickly here, but that way then you can pause at each bit where I do the git checkout, look through the code yourself and see some of the other elements that I may not have had time to discuss. We really did work through pretty much all of it though, so hopefully none of it will be a surprise for you. If you do have any questions, as I mentioned earlier, you can find all of my contact details at developer.newrelic.com/relicans. I am Aaron Bassett. Hopefully you've recognized my photo from watching this video. But yeah, all my contact details are there, my Twitter, my Twitch, GitHub, etc. So please do feel free to reach out with any questions or comments you may have. Also, I have published a couple of articles on the Farmstack. They are both available on the developer.mongodb.com. You can look me up by my author name of just Aaron-Bassett. You can see there is a couple different articles here on Farmstack, including the one I mentioned earlier on adding authentication to your Farmstack app, which I wrote in conjunction with my good friend Mark Smith. So thank you very much for your time. I hope this has been helpful for you. I hope you enjoy the rest of the conference. And please, please, please do not hesitate to reach out.